and welcome to the Chemistry Academy. In this video we're going to go over selecting an indicator for acid-base titrations in relation to the Advanced Higher Chemistry course. So you will get questions, usually one in each paper, and most of the time they are in the multiple choice, that requires you to select an appropriate indicator for a given titration. Now in the question you'll be told what chemicals the titration is occurring between, and based on that information you're then to use your data booklet to then work out which indicator would be the best for that acid-base titration. Now, if we just talk a little bit first of all about what indicators actually are and how they work. So indicators are normally, for an acid-base titration anyway, are normally a weak acid in which the acid molecule has a different colour to the conjugate base ion. And it needs to be a distinctly different colour so that you get a distinct colour change within your titration. So for example, universal indicator is not suitable for titrations because it has a gradual spectrum of colours that it goes between. So there's not two distinctly different colours that it can appear as, so it's not suitable to give an accurate endpoint. Whereas something like phenolphthalein, that will either be colourless or it will be pink. So because it only has two distinctly different colours that it can appear as, then that means it can be suitable as an indicator. So because the indicators are mostly weak acids, they do dissociate to form the hydronium ions and the conjugate base ion when they are dissolved in a solution, water solution. IN here just is short for indicator. You will see this equation specifically in your data booklet as well, and again the IN is just for indicator. But because it exists in an equilibrium, it does also have an equilibrium constant associated with it, where again it's the products over the reactants. Sorry, I've just realised I missed a state symbol here. Products over reactants, and again water is omitted because it's a pure liquid, so it doesn't appear in the equilibrium expression. But in terms of how the colour appears, it's just based on your knowledge of equilibrium. So if we have a solution and we are adding more hydrogen ions, so adding an acid, that means that there's going to be extra hydronium ions in the solution, which means the equilibrium is going to shift left, and then it will appear more red in colour if our acid molecule is red. If we're adding an alkali to the solution, we're adding hydroxide ions. Those hydroxide ions are going to remove the hydronium ions, which then means the equilibrium is going to shift to the right, and therefore it will make more of the conjugate base blue ion, so this solution would appear blue. In terms of then how this translates to the equilibrium constant for the indicator, the more products you have, or the higher the equilibrium coefficient is, the more blue the solution will be, and the lower is the more red the solution will be, because the higher the equilibrium coefficient, the more products you must have, and the lower it is, the more reactants you must have. Okay, it's unlikely you're going to get asked a question on that though. It's just sometimes useful to have that understanding of how indicators work, just in case you get asked an open-ended question on them. But this bit here is what you really need to know to answer the questions that are usually in the multiple choice. So when it comes to selecting an appropriate indicator for an acid-base titration, you're really needing to ask yourself where the equivalence point is. So the equivalence point is the point in the reaction that your two reactants are stoichiometrically equivalent. So that means that you've got enough moles of the acid to completely neutralise the alkali, or vice versa. Okay, and it needs to be equivalent on the stoichiometric ratio of the equation. So as we know from balanced equations, it's not always a 1-to-1 ratio between reactants. Sometimes it's 1-to-2, or it can be 2-to-3. Okay, so the equivalence point is the point at which the reactants are stoichiometrically equivalent. That then means you've reached the end point of your titration, and then as we know, that's when we will see our colour change. Now, the equivalence point occurs a specific pH depending on what acids and alkalis you've used for your titration, and it's all dependent on whether they are strong acids and bases or weak acids and bases. So these are the three or 4 combinations that you need to remember. So if you've got a strong acid, strong base combination, your equivalence point, so the range at which the colour change occurs or your endpoint occurs, is in the middle of the steep part of your curve, but really it could occur anywhere within the range of the straight bit, but you're looking for it to be in the middle. That's essentially where the equivalence point is. So for a strong acid, strong base, the pH, the equivalence point, will be at exactly 7 because they're equal in strength. It's not like one's going to pull the pH to one side of 7 compared to the other. So you'll have equal concentration of hydrogen ions or hydronium ions and hydroxide ions in your solution at the end point, because neither of them are weak, they're both fully dissociated, so there's going to be no disruption to the water equilibrium. So your equivalence point will occur at pH 7. That means that you want to pick an indicator that works across a pH range that includes pH 7. Okay. Now, like I said, as long as the range of your indicator has part of the steep line involved in it, that's okay. So sometimes where you're given a graph in an exam, it'll show the equivalence point at maybe being just, so like the middle of the line, being just below or just above where the ranges you're being given are. Just pick the one that's closest to it, or at least spans across the range of the straight line. Hopefully that makes sense when you actually see a question. So that's if you've got a strong acid, strong base, your equivalence point will be pH 7, so you want an indicator that spans across the pH range that includes pH 7. If we then have a strong acid and a weak base, so if you think of it like a tug of war, the acid's stronger, which means the pH is going to be pulled below 7, because the acid's fully dissociating, means there's complete dissociation, and then therefore there's maximum concentration of hydronium ions, whereas the weak base is going to exist in equilibrium, so the concentration of hydroxide ions is going to be slightly lower. That means then the pH will be below 7 where the equivalence point is occurring. So in that instance you want to pick an indicator which has a pH range of below 7. Okay. Then you've got the weak acid, strong base combination. Again, like a tug of war, the base is stronger, so it's going to pull the pH of the equivalence point above 7. So you want an indicator that works across a pH range that is above 7. Okay, and the last combination is a weak acid and a weak base. We actually aren't able to do titrations with this combination because there is no defined equivalence point. So this is what the pH against like volume of titrant added graph would look like for that combination, and as you can see there's no steep straight part of the curve, which means there's no defined equivalence point, so you wouldn't be able to get an accurate endpoint, so therefore there's no indicator that would actually be suitable, because the colour change would be too gradual. So we don't actually do titrations with weak acids and weak bases. In that instance you would have to find another method of analysing, or potentially do a back titration where you're carrying out a reaction first and then titrating to find concentration of an excess. If you are looking for help on the back titrations, you might want to check out my video going through back titration calculation, because they don't always come up in the exams, those questions, but when they do they are worth a decent amount of marks. So that's what you really need to remember, and the pH ranges of the indicators will be in the data booklet, although sometimes they do give them in the multiple choice question next to the indicator. So if you see them in the multiple choice question, just use those pH ranges. If they just name the indicator and don't give you the pH range, then just go and look it up in the data booklet, because they should all be there. The trick is though is that they won't tell you that it's a strong acid and a strong base, or a strong acid and a weak base. They will just name the acids and bases, so you need to know what are the strong acids, what are the strong bases, what are the weak acids, what are the weak bases. So if that's something you need to work on, you're not sure which acids are strong or weak and which bases are strong or weak, go and check out my strong acids, strong and weak acids and bases video. There's a couple lists in there that should help you with that. So I hope you find that useful. If you did, please give it a like. Don't forget to subscribe, and I'll see you again soon.